Hey, welcome back. We're pushing on with tree traversal. Now we start depth first search. So there are three different orders within depth first search that we're going to talk about, but all of them are DFS algorithms, meaning that they pursue all nodes, they visit or traverse nodes vertically down to the end of the tree before visiting sibling nodes. So that's maybe not the most technical explanation, but it means that we're going to traverse down until we hit the end of the tree at some point. And then from there, there's a couple of options as far as the order that we do things, but we're working down first, depth first, rather than horizontally, breadth first. So we can break down tree traversal into three main steps. So for any node, we need to, at some point, visit the actual node itself. Like if we're building a list or printing it out, we need to add it to the list or we need to print it out, whatever we're doing. So we have to actually do the visit. Then we also need to explore the entire left side and the entire right side. At least when we're talking about a binary tree, if we have, a ternary tree, then we need to do the first, the second, and the third children. But let's just stick with binary trees for now. So we have to, at some point, explore the node and then traverse the left and traverse the right. And those three things, just by changing the order that we do them in our code, literally copying a line, pasting it above another line, or moving it below another line, will change the output that we get. So with our DFS algorithms, our end goal, just like with the breadth first search, is to just build an array or a list, or if you prefer, just print them out. But basically, we want to visit them in this order. And pre-order, which is what we're starting with, basically means you're going to visit the node first. Then we look at the entire left side, we traverse the left, then we traverse the right. And that's true for any node. So we start off at 10, we visit it, meaning we add it to our list, or we print it out. Then we explore the left side. So that means starting off at 6. And so we visit 6, meaning we add it to our list or print it out. Then we traverse the entire left side, then the entire right side. So that means 3 and then 8. There's nothing to traverse after them, so they get visited. Now we go back to 10 because remember, we visited 10, then we looked at the left side. Now we have to look at the right side of 10. 10 was still waiting to have its right side visited. And so we get 15 and then 20. So we have those three operations. We visit the node, we look at the left, and we look at the right. Just by changing the order that we do those in, we'll have a large, very drastic impact on the output order, the actual traversal order. And so we're going to talk about pre-order in this video. Then there's also post-order and in-order. They are all depth-first search algorithms, but they're different orders, and we just have to shift 1 or 2 lines of code. So here are the basic steps that I recommend. You can do this iteratively. It's definitely shorter and easier to do it recursively. So again, if you haven't done the recursion section or you don't know recursion, I definitely recommend you review that section. Okay, so we're going to create a variable just like we did before to store the values that we visited. So at the end, we'll just return that, call it data or visited or whatever. Then we're going to create a variable called current and just store the root of the tree in there. So that's where we start off. Now the slightly tricky part, we're going to write a second helper function. So we're going to have our pre-order function takes no arguments and our second function, which takes a node in, it accepts a node as an argument. And all that it does is we push the value of the node to the variable that stores our values that we return at the end. So we visit the node by adding it to the array or to the list. Then we check if it has a left. If it has a node.left property, we're going to recursively call the helper function again, and then do the same thing on the right. If it has a right property, call the function on the right. So basically, we have this helper function where for a given node, we start with the root, we push that node to the list that we're looking at, to our end result, our data. So we visit the root, and then we recursively do the same thing for the left and the same thing for the right. So we'll walk through how this works in the solution. We'll look at a call stack. It can be a little bit crazy to try and visualize. But if you can just write a helper function that accepts a node, it takes the value of that node, pushes it to our array that we return at the end. Then we check if there's a left. We call the same helper function. I would just call it traverse. We call traverse on the left side of the node. And then we also, the next line below, if there is a right property, call traverse on the right side. Then we're going to invoke that helper function with the current variable, which is started at the root. Where is that? Right here. and then at the very end, return the array of values or the list of values that we've visited. So I know it seems intimidating. If you're not comfortable with recursion, I totally get that. This is this is pretty much word for word, well, not word for word, line for line, what you need to do. You can do the solution in just a couple of lines, maybe 8 lines, 7 lines. And once you get this one, it's very, very similar to the other two, the 2 other depth first search orders. So try it out. Don't get discouraged if you can't do it, because in the next video, I'm going to have a pretty thorough solution where we actually walk through step by step how it works.